Good day, everyone, and welcome to today's DevOps.com webinar. Excited that you've joined us. We have an awesome topic. It's best practices of infrastructure as code with Terraform. The webinar is sponsored by HashiCorp. My name is Mitch Ashley, and I'll serve as your host and moderator. A few housekeeping items. Our recording the webinar will send an email out to all attendees with a link to the recording and to the slides. We also are giving away 3 Amazon gift cards at the end, so stick around and find out who our winners are. Our speaker today loves questions, and we love to answer those for you. So pop those into the questions tab of the GoToWebinar software. So let's move on to our topic, best practices of infrastructure as code with Terraform. It's my great pleasure to introduce our speaker today, Rosemary Wang. She's a developer advocate with HashiCorp. Welcome, glad to have you on, Rosemary.
Thank you very much.
Yeah, we are going to start with a couple of poll questions to kind of get things flowing here. So I'm going to launch this first poll, and while I'm doing that, and folks are responding to it, why don't you go ahead and introduce yourself, Rosemary?
Well, hi everyone. I'm Rosemary Wang. I'm a developer advocate from HashiCorp, as Mitchell pointed out. I'm going to move off of main desktop mode just so that everybody can take the poll and we can actually do it undistracted. But as a quick note about myself, I am on various social media platforms, so feel free to reach out to any of them. I'm also on Twitter and LinkedIn. You can also find me on GitHub. I focus primarily on Terraform and infrastructure as code, but I've been in the DevOps world for quite some time. My first role was a DevOps engineer, and that was a pretty fun opportunity to learn about private infrastructure, public cloud, and some more interesting approaches to managing servers differently. And over time, I kind of switched my way over to infrastructure as code and more public cloud. And I'm noticing that as we go through the poll, we have a variety of experience levels and backgrounds, and that's why I always enjoy doing the poll, just so that I can tailor the presentation a little bit closer. So we're going to close the poll, and it looks like oh yeah, that's cool. So a number of you are trying to get started with infrastructure as code. You're managing teams in DevOps workflows. And there are some concerns about policy and integrations as well. So we're going to definitely chat through the top 2 as well. And some of at least give a brief shout out to integrations and ecosystem and putting policies in place.
Great. Let's go ahead and do our second poll, which is, do you use Terraform today? Just get an idea for where the audience is there. Let's say just a little bit about, I love your journey that you kind of come by DevOps honestly, right, as the saying goes, that you got started. What was your next evolution in your career path to where you are?
So I realized that I was doing a lot to educate others and also educate myself about infrastructure as code and DevOps. So I decided that I wanted to expand that on a much larger scale, and that's where I turned into developer advocacy. I really enjoy the engineering aspects, but I also love hearing from practitioners and people who are using the open source features and looking for something more out of it and looking for the Terraform specifically to streamline their day. And I think that's the best part about being a developer advocate.
I think you're in the perfect job then. Here's our results, by the way. Looks like we've got just over half folks that are using Terraform already.
Yeah, this is great to know. So a little under half are using the open source Terraform. So we'll definitely go through that today. And quite a number also do not use Terraform. So the way we're actually going to structure this presentation is that it's going to have a little bit of everything for everyone. It's going to be a very nice overview. And so we'll get started with Terraform and give some challenges and how Terraform addresses them. But then we're going to go into more the collaboration and scaling aspect, where that's a lot of the questions from open source users that I get. So let's just start a bit with some of the rationale behind Terraform and infrastructure as code. And what I'm going to do is enter full screen, but if it flip-flops back and forth, I am so sorry. Unfortunately, it will keep doing that. So what happened with infrastructure? And this is actually where I started my career. I was working in a data center, and when I would configure servers or switches, oftentimes I would have to have special access or specific wired access to do that. And it was fairly static in nature. So what we ended up doing was trying to figure out how exactly to, sorry, there's a little bit of noise I'm trying to get, oh, there we go. Okay, so there was a little bit of an effort to try to figure out how to actually automate all of this, because even though things were very homogeneous in general, all of the servers generally had the same, pretty much the same specification with like really snowflake kind of configuration. It was pretty difficult to do. And over time, I realized in my career that everything started to be more dynamic. I couldn't rely on IP addresses to tell me identity anymore. I would sit there and be like, oh, I have the CIDR block and I know it belongs to this application. And that wasn't true anymore. With dynamic infrastructure, we could do whatever we want to with the services that are available on public cloud, for example. So if I wanted to do serverless and I wanted functions on demand, I could use any of the serverless offerings from Amazon, Azure, or Google. And I wasn't going to get a guarantee on the IP address or the identity. It was always going to change. And so the shift to provisioning dynamic infrastructure became more and more difficult to manage. I remember going into the console for Google or Amazon, and I would sit there and basically create a lot of instances by hand and then connect them up to virtual private networks. And then when I decommissioned them, I got a cloud bill that was like $200. And I was like, why is this $200? And I realized that in my decommissioning process, I forgot to decommission Elastic or public IP addresses. And that was the cause for $200 cloud bill. And I realized it just wasn't going to work anymore. So in an attempt to figure out how to automate this and how to make it easier for me, I looked at something called infrastructure as code. And the idea is that we have very dynamic environments and very dynamic infrastructure. So why don't we codify it? Why don't we try to automate that and basically create code that is a reflection of our infrastructure or the infrastructure we want? So here, as you can see, if you don't understand the code, that's okay. The intent is not for you to understand the code as much as just understand the complexity of architecture. Architecture diagrams don't really work anymore when you're constantly changing. It's not like we can depict whether or not an AWS Lambda is at this IP address and how it's connecting to an Elastic load balancer when there's now a lot of load balancer offerings, and we can't really make that decision, and we can't really reflect that in an architecture diagram anymore. So the reasonable way to approach this is to maybe codify it. But there are some challenges. And today what I'm going to do is boil down Terraform to solving certain challenges that you're going to start with when you actually begin your infrastructure as code journey. So for those of you who are just getting started with infrastructure as code, or you're just going to learn about Terraform, there are many Terraform Learn resources. I'll include them at the end. We're not going to go through every single command. That would be pretty tedious and not something we can cover in an hour. But what I will do is actually formulate Terraform around the challenges that you might encounter when you first start. And then after you first start and you grow with it and you use it more, you'll reach a point where you're going to have some collaboration and scaling challenges, and we're going to talk about those as well. So we're going to go through this little journey together. All right, so infrastructure as code challenges. What are some challenges that you'll start with? Why do we start with it, and how is it such a barrier to entry when you first do it? Well, infrastructure as code can mean a lot of things, to be honest. At the core of it, it boils down to applying software development practices to infrastructure. And there are a lot of software development practices. If you actually look at the number of books and the number of wiki articles available, you'll find that you will never be able to consume all of them in your career. And I certainly found that to be a case. So what are some of the main goals that we want to accomplish by using infrastructure as code? If we boil it down to outcomes, maybe we can better describe what we're looking for out of infrastructure as code. The first thing is that we want to unify the view of resources. We want to support the modern data center. So this could be all of our SaaS offerings, all of our infrastructure offerings. It could range from our private data center that has fairly homogeneous servers all the way to the Lambdas that I was talking about in AWS. So the idea is that we need to be able to support all of those. And we want to view it from, in some ways, a single understanding. We want to engage with it in a very similar way. And I think the third piece, which is the most important goal and outcome for infrastructure as code, is to expose a way for individuals and teams to safely and predictably change your infrastructure. Change is difficult for infrastructure. I have definitely seen a BGP route change that has taken down an entire network, right? So it's not exactly the safest change that you're going to make, and some are just very high risk. So how do we do infrastructure as code safely and predictably? We're also going to try to look for a workflow that's technology agnostic. It doesn't really matter about the tool, but as long as the workflow suits your development team or the way your team works, then you can at least say, hey, it doesn't matter if I'm deploying to this cloud or that cloud. It's all technology agnostic. It's multi-cloud. And the last piece, which is most important as an outcome for infrastructure as code, is managing anything within application programming interface. Now, this doesn't just mean REST, which is a protocol, but the idea is that you can manage it with some kind of programmable interface in general. So just because a resource doesn't have an application interface or a good interface doesn't mean you can't do automation or infrastructure as code against it. So see, these are the outcomes that we want, but we actually get some challenges, right? And the first thing that I remember when I started infrastructure as code, and I actually started in some ways educating about it, was that we need to learn to code. And it's a big factor for a lot of people to not do it, right? Because coding is very difficult. Doing it in production is even more difficult at times, and people study for years to do it correctly. And the reality is that as operators or engineers or people who are in the DevOps space, we don't always have the time to learn to code. And so how do we actually solve this problem? Well, Terraform kind of does, so I'll explain that later. But more importantly is that, let's say we just can't automate a resource. Forget about learning to code and not having time to do it. We have to sit and figure out how to automate the resource and what's wrong with it, logic, and we have to program some edge cases and make sure that it's not failing on us, right? And that's not that easy either. The next piece is we can't really track changes in infrastructure as code because someone could just change the code and deploy it, and then we wouldn't know what actually happened to infrastructure. It seems like someone could go rogue, which isn't great. And then on top of all this, there's the challenge of not understanding change impact. It's hard to tell when you have this, giant blob of code, what's actually going to happen. So, why bother going to infrastructure as code if I can't tell what change impact I'm making? And the final piece is that you need to maybe revert a change sometimes. If you're doing change review, in some ways, it's pretty easy. You think about this pretty thoroughly, right? You submit the change with the paperwork and the documentation of how the change will go. And you also think about how you roll back, right? They ask you to say, how will you roll back if it doesn't work? And you go through review by two people who say, 2 or 3 people, sometimes even more, that the change is good, it's legitimate, it can roll forward, it can go to production. And reversion steps are generally well accepted. So in infrastructure as code, you don't know what side effects you'll have if you do revert a change because maybe it will cascade to other pieces, right? So there's a lot of, in some ways, fear around this automation cycle. And then after you've maybe gotten over those initial hurdles, then you're like, oh, but this doesn't scale. The way I started to do it doesn't work anymore. So this is the second piece of this webinar, and I'll go through this later once we actually set up the initial challenges. But as a quick glance, these are some of the initial scaling challenges you might have after you've even gotten started with infrastructure as code. All right, so here we go. Here is the beginning. So let's say we want to do infrastructure as code. We need to get started. Let's actually go through each one of these challenges and see how it's solved by Terraform. So once again, reiterating, these are the initial challenges: need to learn to code, can't automate a resource, can't track changes, don't know change impact, and we need to revert a change. So let's actually see what pieces of Terraform fit into all of these challenges and how it might help a little bit. Okay, so every time I do infrastructure as code, someone tells me I need to learn to code. And what's interesting about Terraform is that it's not technically code. It is code, but not in the way that you think. The code, as you can see here, looks a little bit like this. And it says there's a resource. There is a Google Compute instance, and it is going to be named test. It's going to have a machine type. I can tell it will be in US Central 1A, that's the zone. And there's like a boot disk here. It looks like it's going to be a Debian image for this instance. So based on just reading this alone, I can say, okay, I'm going to create a Google Compute instance on Google, and it's going to be a Debian operating system, which is actually pretty nice. So what did we learn from this exercise of actually reading through some Terraform configuration? Well, it's actually a configuration language. It's not really a programming language, although it does have some pieces and functionality that allow you to treat it as such. The language is about intent. A lot of the times when we look at code or we look at scripts, it's not always clear what it is used for. And that's part of the problem with code. You can definitely stray away from good coding practices like naming variables correctly, naming the intent of functions correctly, right? So the idea behind this language here that you see is that it's intent. And so when we actually describe intent, we say, okay, I declare, therefore I am. So if I declare that these resources are going to be of this configuration and of this intent, it will be in the configuration. So that's what's important about knowing Terraform. It is declarative. A lot of things are declarative in nature. So if you declare something, it will exist and it will be the configuration. So the last piece, which is really neat about Terraform, is that under the hood, Terraform is handling the logic of calling APIs and dealing with changes. So you're not necessarily going to have to write code or write scripts to figure out, okay, did I delete this virtual private network first? Did I delete this policy group first? Where did this go? What it basically is doing for Terraform is just saying, okay, I'm going to handle this logic for you. And if let's say it's an in-place change, I will handle that logic. So that's what's kind of important about knowing how Terraform works as code loosely. It's really less code and more configuration, but it's actually oriented to describe the intent. So as you can see in the previous one here, you can see that it's pretty much going to tell you what you're going to create. All right, so what if, you started to learn Terraform, you go through the learning and get started and you go like through this documentation that tells you to create a resource. But what if you have a resource that you want to automate but really can't? So let's say this could be a Cisco switch. This could be a vSphere instance. Well, the good news is that if you can't automate a resource, well, you can probably find it on the big list of providers that we have in Terraform. And most of these either are written by community, they're supported by HashiCorp, or they're supported by the vendor that is going to, that the resource belongs to, so to speak. For example, here we have Heroku, we have Google Cloud Platform, we have PagerDuty, and some of these are actually written in a way so you can interface with the resource with Terraform. I actually have this link here, terraform.io/doc/providers. So if you're interested, feel free to take a look. But you can manage many other resources beyond the physical machines and network switches. You can do that for alerts. You could do it for a lot of things. And the idea behind providers is that it's an ecosystem. So in the polls, remember we talked about ecosystems and integrations. Well, these are generally ecosystems and integrations. They're the ones that lend power to Terraform. So besides Terraform, the language, this is actually where Terraform, the ecosystem and the integrations come in, and you can actually use them. Now, many of the providers are community maintained. I give that caveat. So sometimes things don't make sense in terms of the language. So make sure you read the documentation really well. Make sure you understand the vendor that you're using and the constructs that they're offering. So in this example here, I'm creating a new Datadog monitor. That is the language that is used by Datadog for their alerts, right? So it's called a monitor, and the resource itself, right, becomes the monitor. And so here you can tell I have thresholds that I'm configuring, and the threshold says if it's 4, then it's a critical and I should alert. So I'm able to still read it no matter which provider and which integration I'm using. And so if you don't have anything for that resource, if for example it just doesn't exist, you can also write your own. There's the Terraform plugin SDK. It's an interface for you to work with Terraform, and you can write your own provider if you need to. I've certainly done it. And if you're curious to learn more, there's a link down at the left-hand side here when I distribute the slides, and you can go to that. Now, beyond the understanding of current providers and maybe writing your own, what's a common misconception that I see actually about Terraform? Well, if you notice here, the resource is actually specific to the provider and the vendor. So the reality is there is not a common data model across clouds. So if you want to say, hey, Rosemary, can I do infrastructure as code by saying the same exact resource, like resource virtual machine, and that's all I need to say for Google, AWS, and Azure, and maybe even my private cloud, I will tell you that that's not the case. Every resource will be tied to each provider and each vendor. So there is not a common data model. It's not like Network Yang, for example. So you will have to declare a different set of languages and abstractions for each individual cloud provider. So that's a caveat. A lot of people ask the question, like, can I just declare once and then I use it across all clouds? And the answer is no, you do have to configure each one separately with different syntax. All right, so let's actually look at the next challenge, which is we can't track changes. We don't know if someone actually deployed something. We can't tell if someone did something. And quite frankly, we have no way of determining whether or not, what changes were made because someone deployed it with code. And I'm here to look at this because I actually can tell a difference, and that's actually neat through Terraform. So what you're seeing here is actually state. And so state actually has some indicator of what is going on in that environment. And when you change state, the idea is that it allows you to track changes within your environment. So here you can see that I've created a new AWS instance. I've got new IP addresses. I've got new volumes. So here I'm able to actually see that difference. And this is actually a screenshot from Terraform Cloud, which is the software as a service offering for Terraform. I'll explain a little bit about that later. But the idea is pretty much across the board in Terraform, it tracks state. So that's the important concept. All right, so when I talk about tracking state, it's usually a bunch of metadata. In this case, it's a JSON file. And so when state is actually changed, what it will actually do is tell you that, hey, state has changed. This is the information that you have to know about it. When changes are applied using a Terraform apply command, what you're actually going to get is a writing back to state. So we'll say, okay, I'm going to write back to state all of this new information. So it's really important to make sure that you have state enabled and you are tracking it in Terraform. Terraform does do it for you, so make sure you configure it correctly to do that. Something that's really important to know when you first get started with Terraform is that the non-Terraform resources are not automatically added. I get a number of questions to say like, oh, if I have something in Amazon or Google already, can I just port them into Terraform and it's automatically imported in to state and managed by Terraform? And the answer is no, it's not automatically added back to Terraform because again, Terraform is declarative. It says, I declare, therefore I am. But if it doesn't know it exists in the account, cloud provider account, for example, it will not otherwise know what to do. So you can not automatically, but you can import resources to Terraform state, but it will not generate configuration. So that's the difference, right? There's configuration, which I showed in the first segment, and then there's state, which I'm showing now. Configuration is not the same as state. So state is current state and configuration is I declare the intent. So once you import something into state, you can't necessarily say I'm going to get configuration from that state. The idea is not automatically generated. And again, you can actually manually go through and update your configuration to reflect in state. But just keep in mind that you will have to go through and build configuration. So you will have to write that resource file, and then you can actually use that resource as part of Terraform. Now, manual changes also get overwritten. If you're in a cloud, for example, you might get them overwritten. So just keeping in mind, if you make some changes upstream in the console, Terraform will actually overwrite them. So that's a bit about state. Now, what happens when you don't know change impact? I went through this whole series of, how you assess change impact within your organization, and that tends to be change review and, get someone to review it. Well, The good news with Terraform is that if you run a dry run, which is called Terraform plan, if you run a dry run, you'll actually see how the changes will impact something, right? So in this case, let's say I'm creating a VPC in Amazon. You'll notice that it just says I'm going to create it. So for the most part, it will tell you what's going on. It will tell you what will impact, what will change. Now, how does this do this under the hood? I know you're not going to be able to see all of the text on this page. The idea is not to see the text, but to look at the graph overall. Terraform uses a bit of graph theory to actually map dependencies between all of its resources. So when I run a Terraform plan, what it's doing is it's traversing each part of this graph and actually ascertaining what are the dependencies. If I make a change to, for example, subnet, does that affect, my Kubernetes cluster? Does it affect my region? What is affecting what? So it actually understands what these dependencies are. If you're curious to learn more, you can issue the CLI command Terraform graph, and it will output some text, and you can put it into your favorite graphing device. So it's actually very interesting. You can debug dependencies that way. So when plan runs, what it will do is actually tell you, okay, here is a resource. It has this dependency. As a result, these dependencies will be created, destroyed, updated in place, and destroyed and recreated. So something to be really vigilant about when you see the dry run, if you have a database, so maybe I created a database and it's being managed by Terraform. Maybe I want to update the configuration of a database, but the configuration requires that it needs to be destroyed and recreated. Like I can't just update it in place. I have to actually destroy it and recreate it entirely. Well, Terraform will tell you that the resource will be destroyed and then recreated. And in that case, that's a flag for you to say, I don't want Terraform to do that. So you can tell Terraform to ignore it. So you can taint it. You can tell it to ignore it. You can tell it to not manage that life cycle, right? So you can at least preserve that resource and make sure it's not destroyed. So if you're doing that for a database, it might be really important. But everything else, it will tell you if it's created, destroyed, or updated in place if it can. And all of that logic is actually done by the providers, by the code that's already been written. So you don't have to actually think too much about it. Now, what happens when you need to revert a change, right? So what happens when you make a change and it goes horribly awry and you don't know what happened? So Terraform, I mentioned, has something called state. And for the most part, state can be anywhere, right? I told you it was the metadata file, and that metadata file can exist locally, and preferably it should exist remotely. It should be existent on an external source of some kind. So in this case, right, I have a little snippet here, and what it's actually declaring is that my state will be stored in backend remote. So backend remote means that I store my state in Terraform Cloud, the SaaS provider. And what it's basically saying is that as long as I store the state in an external source, I can always reference back to it. This is really important when you revert a change, because when you need to revert a change, you prefer to have the working configuration. So if you can, version control the working configuration. If you know it works, then make sure it's in version control. So this could be Git, this could be SVN, this could be any kind of version control you're looking for, as long as you're able to go back in history. In terms of remote state, what you can actually do is version the remote state. What you should actually do is version the remote state. And what this will do is say version 1, version 2, version 3, these are the kind of the important pieces. And so when we actually have this, we're going to say, okay, we're going to update to the previous working version. We're going to revert, quote unquote, back to what was the previous working version. And that actually is going to allow us to make sure that we're reverting a change to a working state. What I like to do personally is add a toggle. I have some more information on that, but the idea is that when I say true or false, what it will do is say true, this is a change, it works, it's great, and then I just say, okay, like toggle off, and then it'll be fine. But let's say if I say toggle and it doesn't work at all, then I can quickly go back to false and it removes it. Something that's important about Terraform though, is that remember when I said Terraform plan, it's a dry run, it will tell you what's going on, and then maybe the Terraform the next piece would be Terraform apply, which is to apply the configuration to the live infrastructure. It's not technically a reversion. Terraform apply is always a roll forward. So when you run Terraform apply, it always rolls forward changes. So revert is not technically a revert. You're rolling the pre-configuration forward, and it will not always be perfectly reverted. So I mean that because sometimes maybe the configuration has already gone and there's no real way for Terraform to just completely undo it, right? It's kind of just like, oh, maybe I'll have to destroy it. Maybe I'll have to recreate it entirely. So that's what's important about that. So once we actually figure out all of these challenges, and this is sort of the getting started piece, you know, maybe I'll actually have some opportunity to introduce it to the rest of the team. But I'm going to see actually if this works before I move on, because the next piece will be interesting. But let me actually see if I can show a little bit of what this looks like in practice. So I'm going to swap over. All right, so there is a lovely VS Code here. What you see is that I have a screen of some Terraform configuration. There's far more configuration than I can also show as well, but you can see here that I'm doing a Kubernetes deployment. And what I'm saying here is that I'm going to actually deploy it with the name, with some labels. It's going to have some containers. There's actually variables in Terraform Cloud, so I can pass in variables as I please. So in this case, I'm deploying an Nginx. And the general workflow sort of starts like this. I'm going to run a Terraform init. And when I run Terraform init, what that will do is actually pull down the ecosystem and integration binary for Kubernetes. So that's actually what this is saying. It's saying initializing the backend. My backend doesn't exist because it's doing it locally. So a little dangerous there. When I do a Terraform plan, what this is going to do is execute that dry run that we were talking about. So now I know the changes that are going to be made. In this case, it will add a lot. And then I'll run a Terraform apply. Since this is a clean start, it will pretty much just add everything. And as you can see, it's going to create it. It's going to tell me when it's done. It's also going to do it in order, service and deployment. Now, if I actually look at what this is in state, what you'll see is that it actually looks like a JSON file here. And this is actually representative of the metadata of things that are currently happening. So I'll always have the state file. If it's local, it will be sitting here on my file system. Otherwise, I should specify remote, which is what I showed before, to make sure it's remote. So that's a quick view, very, very quick view of Terraform. And now I'm going to roll back to the second half, which is collaborating and scaling. For those of you who are already using Terraform or you want to introduce it to your team, you're going to run into some challenges right after you first start using Terraform. So I'm going to actually go forward and we're going to chat about scaling challenges. The first thing that you're going to run into when you do Terraform and you start actually rolling it out to different parts of your infrastructure is that there's going to be multiple environments. You're going to have dev, you're going to have QA, you're going to have prod, you're going to have compliance concerns that you can't touch prod, you can't touch QA. So we're going to chat about that. We're also going to talk about duplicate code. How do you prevent duplicate code from happening? And the reason why this is important is that let's say you have a bunch of configuration and all of it is the same. Imagine you had to go through and change all of the names and tags for them. Well, that's not very useful and it's actually pretty difficult to do and it takes a lot of time. So let's actually chat about how we fix this duplicate code issue. The next thing is what I call a ball of mud configuration. This is actually borrowed from a software development term where the architecture becomes this big ball of mud. You can't really sort it out. All of it is kind of done at once. This I'll explain a little bit more about, but sometimes it's really hard to decouple some configuration. So maybe you find yourself spinning up 400 resources at once. So we'll talk about that. The next is you maybe have too many people working on the same body of code. It does happen. Sometimes there are conflicts. So how does Terraform deal with that? And the last two are dry run doesn't reflect change impact. This is pretty common, right? Just because you plan it doesn't mean it actually will happen. So in this case, I'm going to actually check and make sure it does. And then upgrades can be pretty disruptive. So we'll talk about upgrading Terraform. I know this is a lot, so we're going to go through pretty quickly, but I'm going to try to get through it. All right, so what happens in multiple environments? Previously, there really wasn't a good way to manage multiple environments with Terraform. Now in Terraform open source, there's a Terraform workspace command. So when you run Terraform workspace list or where Terraform workspace new, what you'll do is actually create effectively a new environment. As you can see here, what this does on the back end is it will create a subdirectory for that specific environment. So in this case, I've created a subdirectory under terraform.tf.d, tfstate.d, and then dev and prod. Now, workspaces in themselves are existent to isolate state. The reason why it's as important is that when you have multiple environments, you don't want state between environments to get contaminated. So I don't want a production database to have a change if maybe I'm only doing it to dev. So by making sure that state is isolated per environment, we can actually prevent unwanted changes, right, from dev bleeding into production. So that's why workspaces are really useful. Now, something really important to note, open source workspaces are for isolating state. If you're talking about workspaces for Terraform Cloud, which is the software as a service offering for Terraform, what you'll find is that it has more functionality in general. It not only manages and isolates the state, but it also provides the access control construct. So you apply access control to the workspace. It also encompasses a bunch of runs too. So workspaces are kind of expanded within Terraform Cloud, but if you're just using open source and you're not necessarily using Terraform Cloud, you'll find that workspaces are specifically for isolating state. And so when you actually do this in open source Terraform and you go through this process, what you'll see is you'll go into a directory like dev and the dev environment that has all your dev stuff, and you'll go Terraform workspace dev, it'll create the subdirectory to isolate dev state. You'll do Terraform init, Terraform plan, and Terraform apply. So this workflow is generally for isolating the state. Now, what happens when you have duplicate code? In this case, I have a dev and a prod directory under hello world, right? And all of these have separate configurations. I have network, Kubernetes, application, and database. But what's really important about this is that maybe I need to change the network for some reason, and I want to maybe add tags to it. Well, now I have to go through Control F, find the tag structure, add to the tags, and look at all of these directories recursively. And it's pretty difficult to deal with. Now, if you imagine this in an organization or when your teams start to work on this, you'll find that it's not really useful and it becomes really difficult to make changes. So one of the ways that we can actually get around this is to use modules. Something that's really useful about modules is that it allows you to divide resources into different files. So what you can say is network consists of subnets and VPCs, and then maybe there's a Kubernetes cluster, and then there's an app and a database. And here, what you can see is that I have a base module. So this is all the stuff that I need to create an application. And then what I'll do in dev and prod is say, I'm going to just reference that module. I'm going to call back to that module, which is /base, and create this network, Kubernetes, database, and app. I can pass variables to it to tell it to do it differently for each environment. But the idea is that I don't have to repeat base. So for example, if I change the tagging, I just need to change it in, let's say, vpc.tf, something like that. Modules themselves can actually exist locally, so within the same directory, or they can be version controlled. So they'll either be hosted in your favorite version control, or they could be in a module registry. In Terraform Cloud, actually, there is a module registry that's available, and you can load your modules in, and it will actually grab them from the module registry. What's important to know is that when you reach about 500 modules, it's no longer practical to do all of it like saying git, pull it from git, pull it from git, pull it from git every time. What people encounter is that they'll actually get to like 500 of these and they won't be able to pull it from git anymore. So what they'll do, and what has been working for them, is to use git submodules. So it's actually local, like it's given the illusion of being local, but it's still version controlled in Git. And what this will do is make it a little faster to retrieve those modules. But the other option and solution to that when you hit that point of scale is to just use the module registry. Okay, so we talked about specifically module in the large level and the directory, but what does it look like when you actually use it? When you use it, you're going to actually do this source command. So when I mentioned before about pulling it from Git versus pulling it local, here you can tell this is going from the source. The source is a module registry, so in this case, it's an ELB module. And it will actually tell you, okay, here are some variables, these are required, and then I can still grab the outputs. So that's what you can see here, module.elb this, ELB DNS name. So I can still retrieve outputs from that module. Now, as a general rule of thumb, when you start to do this, do not set the provider version in the module itself. So Terraform AWS modules, ELB AWS, does not have versioning in the provider. So when I want to download that integration, it's best to version control it, right? Because just like any RPM file or any kind of file or binary that you want to download to your system, you want to make sure you pin the version. Here, the modules themselves do not pin versions. You should do it in the consumer. So here, I'm consuming the ELB module, and therefore I pin the version. So I tell the version that I want. Not the module itself. So if you're writing modules, don't put the version in the module, put it on whoever is actually consuming it. So it's a little bit easier. And that way, let's say if you want to use 2.41 in dev, you can keep prod, for example, as 2.11 or something. So you can test out the upgrades. And make sure you version with some tagging too. It's useful to tag everything and make sure it's all versioned. All right, so what happens with ball of mud config? Ball of mud config is what I call basically 300 resources all squished into one set of configurations, and it takes 20 minutes to actually create. And so I'm not going to go too deeply into this because it's actually something that requires its own talk entirely. But there's a resource at the bottom from Keith Morris about how you can break this down. So make sure you can, when you reach this point where you have 300 resources in one file and it takes 20 minutes, what you can do is decouple using data sources. And in Terraform, this data source basically reaches out to your provider or your integration and says, hey, give me some information. And then you can dynamically pass that in. So that's where this data AWS VPC selected ID comes in. And you can run them separately. And the idea is that way you don't have 300 resources, maybe you run them 100 at a time. All right. What happens when too many people are working on code? This is what happened with me and my teammate Eric the other day. As you can see, both of us were changing routers and we were kind of overstepping on each other. The way that Terraform deals with this is a concept called state locking. But I'll explain that later. But the idea here is that I'm just basically working with my teammate and all of us are trying to figure out what's going on with it, right? And part of the problem was that we didn't agree on exactly software development patterns. So some people want to do feature branching versus trunk-based. Again, I won't go too deeply into these. If you're curious to learn more, there are certainly a lot of articles out there about both approaches, but these are some patterns you might consider when you're talking with your team on how to do this. The next piece is mono versus multi-repository. When I said there were 300 modules or 300 resources that need to be created by Terraform, that tends to be the mono repository approach where everything is put into one repository. Eventually you reach a scale where you have to start breaking down everything into multiple repositories. So that's the idea behind the development patterns. But besides establishing collaboration patterns, make sure you put it in some kind of pipeline. That way it controls who's making changes, how and when, and you can actually audit the changes based on code push. And the most important part about Terraform is that it locks state during changes to prevent overrides. Not all state backends support this. So if you're using something that's tends not to be common, then it won't lock state. So make sure you lock state during changes, and Terraform will actually pretty much do that with most backends. And what it will do is just stop people from making changes while you're making changes. So it only allows one person to make a change at a time. Now, the last couple pieces are like what happens when dry run doesn't effectively change correctly. Like, so if I do Terraform plan and it still doesn't work. So in this case, for example, I still can't SSH even though I ran the Terraform plan. Well, Terraform can't tell you if something's going to work or not. It can't tell you really whether or not your config is correct. So this is where testing comes in. I have a link to more information down at the bottom, but when you do testing, that is outside of Terraform. Terraform itself is not responsible for testing. It is responsible for telling you what dependencies might change. It might reflect change impact, but it's not necessarily going to tell you whether or not it works. So you still have to test. You still have to make sure your infrastructure is working. even if it means, like in this case, I SSH back from application to database. So I still have to run this test and say, did I SSH correctly? And finally, upgrades. Upgrades can be complicated. There's, again, a whole talk on this one too. But once you upgrade Terraform, you can't go back. Actually, as you can see here, once the state reports that it's up a version, you can't go back a version. So I can't go from 0.8, for example, to 0.7. So once you upgrade, you can't really go back. You have to actually go fix the upgrades, right? This is a cheat sheet that I have for upgrades. So if you're really hesitant about upgrading your Terraform, this is at least my cheat sheet for determining what would change and how it would impact. As you can see here, we're currently at 0.12. This one was a big change for quite a few people. So there's kind of more information on this as well. Now, what do you do by easing the upgrade path? Like, what are some ways that you can fix this? Well, first of all, pin the provider versions. I can't specify this enough. Pin those provider versions. Make sure when you get started from the very beginning, you're pinning them. You're making sure you're versioning it. Use known functions and don't use the creative hacks because those can get really, really difficult to actually upgrade. Creative hacks, you'll know it when you see it. Basically, someone's using kind of like not standard functions to do things. Decouple your configuration across providers. This is something we actually talked about sort of in the modules and also in the ball of mud configuration. We want to make sure we just decouple as much as possible. And something that I see is that people will squish the Kubernetes configuration with the actual Kubernetes cluster configuration, whether it be in GCP or AWS. So the problem is that they'll put both of them in one repository, and then when they upgrade, it breaks everything. Keep them separate. You know, generally, if you're deploying the application, for example, on Kubernetes, keep that in a separate repository. Don't put it in the same one. Also, avoid provisioners or complicated lifecycle customizations. There's a term in Terraform called provisioners, and it will execute, you know, a command for you if you want it to. It will execute a shell command. And while they're useful, sometimes they have different behaviors depending on when you upgrade, how you upgrade, etc. So just make sure you try to avoid provisioners. Try to do it as part of your CI framework or your pipelining. All right. So in sort of wrap up, what we talked about were challenges. We didn't really go too deeply into every single command of Terraform and every single nuance and internal. So if you're curious to learn more, definitely look at some of these links. They'll talk more in detail about Terraform getting started, sort of the ins and outs of the CLI. And there's also Terraform Cloud. It's a great way to get started on some of these concepts without needing to set it up yourself. So if you're interested in sort of learning the concepts and getting a little bit more used to remote state locking, understanding dry runs, changes, seeing the diffs, definitely sign up for a Terraform Cloud account and also use learn.hashicorp.com/Terraform to learn more. And if you ever have questions, feel free to post in the community forum. And if you're interested in these slides, I believe Mitchell mentioned that they'll be distributed as well. You can always reach out to me at any of these particular social media channels. And now I'll turn it back to Mitchell.
Great, thank you. Fantastic presentation and walkthrough. There's tons of information here that we learned today. I'm going to pop up another poll, and while we're doing the poll, we'll go ahead and take some questions that we've received from our audience. So if you go, the participants, if you go ahead and fill out this poll. The first question, which I think you'll enjoy, is what do you recommend for keeping secrets in Terraform? Obviously, you don't want to put secrets into scripts and things like that. What would you recommend?
Yeah, so when it comes to secrets, it's actually very interesting. There's a whole set of descriptions around how that's managed. So some secrets, for example, should not be in your Terraform scripts, as you recommend. And the answer for open source isn't always HashiCorp Vault, right? I can acknowledge that. So
it's a good answer, though.
Yeah, it's a great answer. It's a great tool. But if you want to do it without using Terraform scripts, certainly look into environment variables. I like using tf_var_ the name of the variable. And what that will do is actually set the environment to be using those variables. And that's actually a lot better. It doesn't show up in state, for example, and it won't show up in the scripts. Some things are unavoidable to show up in state. So something like when you create AWS access keys or GCP access keys, those will show up in state. So be very judicious on who has access to that remote state in particular. But in terms of overall secrets, I like using environment variables. I'll source them from like a file, for example, and set them as part of my environment. But there are a number of folks who will use secrets management as well.
Great, awesome. I think you may have referenced vCenter, VMware, ESXi previously. Question came from the audience that we don't have vCenter. Do we have to have that, or is it just one of the environments that you were walking through with us?
Yeah, so certainly you can use any of you can definitely check the providers page. I believe we do have ESXi. A number of folks really enjoy using the vSphere Terraform provider. So not just vCenter. So.
Okay, great. Next question is, can I manage Terraform code with any version control system, like Git, for example? Is it recommended? What are some of the options?
Yes, so it is highly recommended you manage your Terraform code with version control. We have GitHub, GitLab, Bitbucket, pretty much anything that's Git related you can use. It's actually a very good practice to do it, mostly because you can actually see who's made the commit. For me personally, I like making the message like I'm adding a router. Like as you can see, I changed the router, for example. And it's a bit like my change audit log. So definitely use a version control system.
Okay, excellent. I'm also going to pop up another poll, the last one, just if you have any interest in Terraform Enterprise here, so our audience can express their interest in that. Next question is, if I need to destroy some part of Terraform resources, do I need to write another Terraform code, write some more code to do that? How does that work?
Great question. So a command I didn't show here was Terraform destroy. So you do not have to add more code or write more code to destroy the Terraform resource. Once you have the resources in state, you just run Terraform destroy, and it will actually undo all of those resources and check for all of the dependencies. So no more dangling elastic IP addresses that give me like $200 cloud bills. So none of that anymore.
I had that happen with the SQL Server one time. I appreciate the expense of that. Next question is there a plan to add a feature for importing existing infrastructures when initially migrating to Terraform?
Yeah. So there is a feature out, there's a feature request out there. We're certainly looking into it. It's a little bit more complicated, mostly because then it's sort of like backporting dependencies. There are also community written tools out there that will actually import resources from different cloud providers. So certainly reference those. But in terms of within Terraform itself, there is a plan to, but the nuance and the sort of technical difficulty of it is a little bit more difficult to vet. So.
Okay, great. It's good to hear that folks can contribute those kinds of things. Do you have any suggestions for managing in a CI pipeline when moving resources between configuration files?
So in terms of managing state in CI pipelines, definitely looking at the backend configuration. So in this case, you can choose if you're not doing Terraform Cloud, like I was showing here, you could use S3, you could use GCP, you can use a variety of different tools and different products that will allow you to store state. It's basically a metadata blob. Now, when you're moving the resources between files, for example, it will actually not change much. It's already in this whole state. So if you're moving from like one config to another config, it really won't mess with it because it's already reflecting that. But just making sure that you are actually keeping it in remote and you're referencing that same remote state when you're doing the move will go a long way to actually for Terraform to say, oh, nothing changed. It's just, someone moving it around between configuration files.
Okay, great. I'm not sure if I understand this next question. Maybe you can help fill in the gaps if it makes sense. But what's the best way to reference resources in a different model?
So the best way to reference resources from, let's say, cross-provider. So great example of this would be like Kubernetes, Google and Kubernetes, for example. The best way to go about this is to use modules and use a well-behaved module output. So to say like module.kubernetes cluster.kubeconfig, for example. And that will allow you to get outputs between providers. without necessarily having to dig deeper into the resource per provider. So if, let's say, you're doing multi-cloud and you want to access like a DNS from DNS name servers from AWS to populate into Google, for example, you would have the best way to do it would just to say module.aws.dns servers, and just make sure that it's passing through that module output.
Okay, it's module that they were asking about. That makes more sense now.
Well, there's a couple ways to
it. Okay, where would we get more information on versioning state in remote backends?
To version state in remote backends, check out the backend that you're looking for. So for example, each backend has its own documentation. In the case of many of the bucket storage in the Google Cloud or AWS Cloud or Azure, for example, each of those you can turn on versioning within the bucket. So it versions the artifacts. So as long as you do that, that will achieve state versioning within different remote backends. With Terraform Cloud, it comes out of the box. Other backends, you will have to look into each document to understand what's going on and how you can turn on that configuration.
Okay, very good. What are the differences between the flavors of Terraform, the cloud, enterprise, open source? Do they all have the same functionality, or are there some differences between the three?
So with Terraform Cloud, it is a software as a service, so we run it, and there's a free tier for it. There's also some additional plans that you can add on top. With Enterprise, those tend to be related to on-premise deployment. So for example, you are not allowed to use third-party SaaS products that are hosted across a public network. You would be looking at Terraform Enterprise. But in terms of Terraform Cloud, there are different tiers, and you can feel free to investigate what works for your team.
Great. How about the open source? Can you say a little bit more about that too?
Yeah. So for the most part, there aren't really missing features from open source. There's not too many divergent features from open source and the SaaS product. You can still do Terraform Plan, Terraform Apply. The providers are all there for you to use, pending licenses for certain vendor ones, right? The only real difference between Terraform open source and cloud and enterprise is the collaboration piece. So if you want to collaborate on other CI frameworks, you have to set up part of that. So you have to set up buckets, you have to set up this, you have to set up that, you have to set up, a pipeline to merge changes, etc. Terraform Cloud just has that all available for collaboration. But in terms of open source, that I've done plenty of them that I just set all of it up myself.
Great. For our last question here, well, let's see, I just had one more come in, so let's see what this is. Terraform defines a static state of infrastructure. There's a need to expand the infrastructure dynamically based on activities inside the infrastructure. Is that possible? So once you've set it all up, can you continue to modify and change it?
So you could continue to modify and change it as long as you declare the changes, right? So as long as you're declaring the changes within the Terraform configuration, that's the dynamics, of Terraform. So let's say a Lambda IP address. If the Lambda IP address is created, that metadata was previously there, but it's not necessarily going to reflect in Terraform that was changed. So in terms of some of the more dynamic aspects, specifically from a metadata standpoint, there's different logic depending on the provider. And so it depends on what configuration is changing dynamically. For example, we don't always track container IP addresses. They're not necessarily used for every differential because they change. Sometimes if they go down and they'll come back up. But the change, maybe the logic internally will say, oh, it's a different version and therefore I apply the change. It's not going to say, oh, it's a different IP address and therefore I apply the change.
Okay, great. Well, it looks like we're very close to the top of the hour. Rosemary, thank you. That was a fantastic presentation. And wow, you know this product well, so that's super helpful.
Yeah, thanks for having me here.
You bet. Well, we'd like to thank the audience too for their fantastic questions, and of course, Rosemary for her answers. Just a reminder that we will send an email to everyone who's participated today with a link to the recording and link to the slides. You can also get them on DevOps.com in the future to get a replay. Let's jump to our Amazon gift cards. We have 3 winners that we want to announce. The 3 winners are Alan J, Jason T, and Thon H. And we will reach out to each of you individually and let you know how you can get those Amazon gift cards. So join me in thanking Rosemary Wang, developer advocate. And so you are a great advocate, by the way, with HashiCorp. And we'd like to, of course, thank you, our audience, for being with us today. Spending a whole hour with us on a webinar. We know your time is super valuable. We're honored that you spent it with us. It's been my pleasure hosting this for you, and everybody have a great day and be careful out there.